the agenda, you'll probably realize that name doesn't match the name on the agenda. My name is Peter Buckingham. I'm an engineering manager at Sun Microsystems, and I'm in charge of a couple of different storage technology groups. Dominic, who is meant to be here today, is English, and we try not to hold that against him. But he seems to think that England is a much better place to be right now than sunny San Francisco. So if you can't tell, I'm actually Australian, and that would be very different from an English accent. So that's yet another conflict. So what I'm going to be talking about today is a couple of interesting storage technologies that we've been developing at Sun that really make it easy to develop a NAS appliance. I mean, you've probably seen a lot of these things out in the community already. Nexenta has a product that they're developing as part of their Open Solaris distribution. And they're doing a few things like that. So what I want to do is dive into some of the technologies, and at the end I'll sort of run through some of the command sequences and things like that. But I think it's interesting to try and have an understanding of the technology rather than, hey, this is the command that I run before we get to that. I'm pretty flexible. If you want to ask questions at any time, do that. If you want to sling insults or make amusing remarks, you know, that's okay too. I can handle that. So let's move on a little bit. So what I wanted to do is start by diving into Comstar. Clearly, Comstar, as a name, doesn't tell you a lot. So it actually stands for Common Multi-Protocol SCSI Target. And what are we trying to do with this technology? Well, we're trying to take, at the moment I've got pictures of Sun hardware. Now, I mean, that's probably looks I work with Sun, but it could just as easily be other pictures of hardware too. If you have a look at the way that server hardware is going, it's becoming very, very cheap, and there's a lot of cost benefit that you have to having a large number of disks associated with servers. So Thumper is a really good example of this, the X4500. And Comstar allows us to do things that typically you would only do with disk arrays. So it gives us a mechanism to turn a server into a NAS target. So we can make it a 5-channel over Ethernet, iSCSI, ISA, all of these really cool acronyms that you can do very easily without sort of passing out a bunch of dollars to disk array vendors. And then you couple that with ZFS, which is an amazingly reliable file system. We have the on-disk consistency, it's the copy on write technology that allows you to go from what you'd see as sort of a fairly standard vanilla NAS, which merely does sort of CIFS and NFS's exports, to something that actually it is, I kind of think of it as a Swiss Army knife of protocols, so that we can go and also support it as a 5-channel target, as a SAS target, as an iSCSI target. So anyway, I think it's great, and hopefully you will too by the time I'm done here. So let's move on. So this is the Solaris storage software stack. Now it's a bit of an eye chart, but what I'd like to do here is to sort of focus on first of all, the breadth of Solaris storage. If you were paying attention last week, we had an announcement that Solaris is opening up its storage stack. I think the last piece of technology was open sourced about a month ago, and that was SAMQFS. And all of these pieces allow you to do an amazing number of things with Open Solaris and Solaris technology. So if we have a look at some of these pieces, it's a bit hard to point, but we have at the top layer sort of the client side and initiator side technology. So 5-channel initiator, iSCSI initiator, OSD initiator. I mean, these are typically the things that you expect to see in an operating system. That you use these things to talk to your generic storage vendors, and they provide that technology to you. What we're doing with Comstar that's a little bit different is we're providing the software for the 5-channel target, the OSD target, the iSCSI target, and we're building that on top of the Solaris storage stack. So this means that it's very simple for you people, the community, for even vendors to take this technology and build a very robust and comprehensive storage solution. So I think that's enough looking at the eye chart, so let's move on. So what is Project Comstar? So I'm going to wave my hands a little bit and elide some of the details, but essentially we have the basic technology here that takes SCSI commands and turns them into VOP file system commands. So if we have a target driver, it comes in and it will map that into a SCSI command that you can use. So you can use a backing store of a file system like CFS. You can use a thinly provisioned file. You can use a raw device. There's a lot of things that you can use to sort of back Comstar. But the flexibility is the fact that we have all of these target drivers that are available to you. Essentially, there's not the breadth of that offering, I think, in any other operating system out there today. There are a lot of iSCSI targets, but I would hesitate to be able to point to somebody to provide an open source fiber channel target or an iSCSI target. Well, actually, anyway, I'm not going to contradict myself too much, I hope. Moving on. So this is sort of a better description of what I just really badly tried to describe to you. So at the top, we have the backing stores. At the bottom, we have essentially the target drivers, the port providers. And so today, we have fiber channel. We also have iSCSI. SAS is in the works, and fiber channel over Ethernet, I think, is going to be coming towards the end of the year. So this wouldn't be some presentation without saying that ZFS is great. So let's all repeat that after me. ZFS is great. And there are a number of reasons for that. I'm not being totally sarcastic, right? Like I say, one of our teams is responsible for building Honeycomb, which is a fixed content storage appliance. And we found that other file systems are just terribly bad at suffering power outages. ZFS is designed to handle this. They're always on disk consistent. You go pull the plug on your system and you're using ZFS, you're not going to corrupt the file system. And that actually is a really important guarantee that you have when it comes to a storage technology. I mean, you don't want to be guessing about whether the disk cache has been flushed or not, or whether the file system actually knows about the disk cache. ZFS takes care of these things for you. Fundamentally, when it comes to looking at the way that ZFS does volume management, it's far simpler than anything else I've ever used, and that includes Solaris Volume Manager, which I would never like to use again. And the Linux Volume Manager, there are a lot of things about using volume managers that are far more complicated than they need to be. I mean, these things are meant to help us, not hinder us from developing technology. So let's move on. So I got to slow down. So what I want to do is sort of dig into a little bit about how we might go in and do some of these things. So as we're talking about before, there are a number of standard things you expect to do out of a NAS appliance. So if you went and bought something from NetApp or some other network attached storage vendor, you'd expect that thing to provide you at least an NFS and SIFS interface. So what I want to do is sort of let's have a quick look about how you would do that today. And when it comes to using ZFS, that's a very simple, seven-step process in order to do that. All of these things that I sort of put up on slides here, they're all available through the Open Solaris website. I mean, there's a wealth of information out there. I must admit that I didn't actually go in and write this from scratch. I copied and pasted a lot of this information from the community websites. And if you have a look at the mailing list, there's a lot of people who are exceedingly helpful when it comes to going in and deciding how you want to configure things. Do you want to use RAID Z, RAID Z2? Do I want to use hot spares? How do I get the smart information from the Z ports and use that? So most of these things that I've got in these slides are a fairly simplistic demonstration about what you can do to get these protocols out of the box. Clearly, you may want to go a little bit more advanced in terms of how you do RAID with ZFS or things like that too. So, with that sort of prelude, first of all, when it comes to using ZFS to create a file share, you want to identify the disks that you have. And one thing to remember with ZFS is that if you actually use the whole disk for a ZFS pool, or use whole disks as part of that pool, then the write cache is enabled by default. And so you'll get some performance gains from that. And like I was saying before, the guarantees that you have with ZFS mean that you'll still be on disk consistent. So ZFS has a good way of guaranteeing that. They essentially will load these things up into transaction groups, and when the transaction group is being written, or at least the last element of that transaction group is being written, then the write cache is flushed. It means that if you fail at some point during that transaction group, you're still able to recover the state of the system as it was before. I mean, there are a lot of details to it, but essentially they have a series of blocks that refer to these groups, and they can go back to the last consistent state. And this is where copy and write is a fundamental win in an operating system technology, or at least a file system technology. So, anyway, enough of that segue. So now I've identified my disks, what am I going to do? So you want to create a pool. So when you create a pool, that essentially is analogous to the way that you would create a volume with a volume manager. And on top of that, you can then create a file system. Now, again, you may well all be familiar with ZFS. One of the nice things about ZFS is that you don't go and say, oh, well, I need to create a file system that is this big. You can certainly prevent it from growing larger than a particular size, but it'll essentially dynamically grow with the use of that file system. So you could go away and create 1,000 file systems on this pool, and you wouldn't have to divide that pool up into little slivers for each of those file systems. You could let them grow as the use dictates. Okay. So moving on. So it's obviously not very interesting to just create a file system. If you have a NAS box you want to create, clearly you're not going to treat your storage as direct attached storage. So you need some kind of protocol that allows you to talk to this box. So the most standard way that we in the Unix world talk to a box over the network is using NFS. And if you have a look at these steps, it's pretty clear that it's very simple to create a NFS share using ZFS. Essentially, there's a property of the file system. You just flip the bit and you're done. So, I mean, the first two steps are more just bookkeeping, really. Really, if you have a look at this, ZFS set share NFS equals on mypool/myfs. I've gone and played with export FS, a lot of these export tabs, all of these things, and this is clearly a very simple phraseology for creating an NFS share. So the last step, and again, I'm sure you're all familiar with how to mount an NFS file system. This is just more for completeness. So let's see. So we've been talking about Comstar. And how does Comstar fit into this picture? I think Comstar is where we add breadth to the storage technology here. It's all well and good to create an NFS file system, a file server, or a sys file server, but we all know how to do that today. That's not really a significant win. What is a significant win is to be able to sort of beat out some of the legacy technology that you might have in your data center today. So it may be that you're spending a lot of money on fiber channel disk arrays. It may be that you're spending money on SAS disk arrays, or you will be soon. Or you might be looking at migrating to iSCSI or fiber channel over Ethernet, because you don't really want to have multiple networking technologies in your data center. Comstar gives you the ability to support all of these things. And you can support all of these things inside of a single server box. That's really powerful. It really is. It gives you the ability to not be tied into a specific vendor for where you get your disk arrays. You can go to the cheapest server vendor or the cheapest cost per gigabyte of your server plus storage vendor. So anyway, what I've got here is some of the steps that we have for taking what is a fairly standard Open Solaris install server and turning it into a fiber channel target. So the first steps that I'm sort of going through is essentially talking about installing Comstar. Actually, I left out the part where you install the package, but the packages are all available from the Open Solaris website, and we just actually integrated into Solaris last week, I think. So this will be coming as part of the later Open Solaris drops. So the first bit that we talk about here is if you have a server and you want to make a fiber channel target, already there's a fiber channel driver that would be attached to that in initiator mode. So we have to convert that to say, hey, actually, we want this HBA to be a target. So what this first step is talking about is how do we go and identify what HBA is in the fiber channel initiator mode. And we need to, the second step is going, well, now that we have identified this HBA and we want to turn this HBA into a target, let's go and convert it to use the QLT driver. And so T clearly in that case stands for target, so it's nice and easy. So we go through, we associate it with that, and down the bottom you can sort of see the differences between the two MDB output streams. And so now we've converted it into a target mode. What can we do with that? So first of all, let's make sure we enable the Comstar service, or the SCSI target mode framework. So again, this is all managed through SMF, which is another very cool thing about Solaris technology. Once we've done that, we want to make sure that the framework can actually see the ports that we've identified to be in the target mode, and we can run that string there. That will give us a pretty good idea of what's going on with that. So, these next steps are more for sort of illustration about how we would go away and do it in the thin provisioning case. And if you remember, earlier we talked about the other back installs that we could have for Comstar. Again, it could be a ZBOL, it could be a ZFS file system, it can be memory, or it can be a raw disk. So this is merely one example of the way that you would go away and do this. So we're creating a thinly provisioned SCSI logical unit, and we just do that by touching the file, and then the SPD ADM command is here for sort of saying how big do we expect this lung to be. And you don't necessarily actually have to have that amount of space available. In fact, I believe that in development, we've created a multiple exabyte thinly provisioned node. And so what you can do is you can create this large lung and just add the storage to it as necessary, but you don't necessarily have to have it all there to begin with, and you can just be a little bit more dynamic in the way that you address those needs. Okay, we've gone and we've created the lung. So there's a step that we need to do to associate the initiator and the target together. And it's a fairly simplistic command that you can see up there. And I'm not going to read out that number because I'm sure I'd get it wrong. So once we've done that, we then, again, move on to the initiator and we force the enumeration of the devices. And then we Oh, I'm missing a slide. So, okay, we enumerate that, and then we actually will run, you can run the format command on the initiator side, and you'll actually see the devices enumerated through format. And once you've done that, it's a pretty standard process to go through and create a file system. So, you know, you go in and create the partition table, you label the disk, and then you will go and establish a file system on that in the way that you all know and love. So I've gone through this a lot quicker than I expected to. So anyway, what I've got here is I've sort of pointed to a number of the Open Solaris project pages that we have in terms of where are the best places to go and find some more information about this. So today what I've covered is the way that you do these things for a fiber channel target, but clearly there are many other target modes that we're going to support in Comstar. And one of the ones that we support is ISER, which stands for iSCSI, extensions RDMA. And initially that's going to be support over InfiniBand. So we feel that that's going to sort of make a play in the sort of high performance computing space where people are interested in, you know, much faster access to their storage. So I think today if you went out and had a bag full of dollars, you can buy a 8 gigabit fiber channel HBA. Clearly if you use InfiniBand, I think it's up to 20 or 30 you know, gigabits a second. So that's much more performant. The iSCSI target is actually available in sort of a testing mode. You can download it from the ISER project page, since that's a prerequisite before we support ISER. I talked briefly about fiber channel over Ethernet, and so that's a project that we're also doing, and I believe that that's targeting sometime later in the year. So there's currently no code available for that. There will be probably soon. OSD is another storage technology that we use that actually is built on top of ISER, and that's a technology that's based on the T10 object standard. And ZFS, you'll know about ZFS. So ZFS is clearly the piece that links a lot of these things together. So that, you know, we can use ZVols, we can use ZFS to export the systems over NFS or CIFS. We have, you know, the reliability of the on-disk guarantees. We've got the checksumming that will allow you to figure out if you have misaligned reads. So that's kind of all I had. And so I think a lot of the details about, you know, if you want to sort of go away and play with this technology, you can probably use the set of slides as a starting point. But I'd really encourage you to go out to the community web pages and look there. The link that I didn't talk about was the one at the top, network storage. So this is an overlying storage community that we have, and that's probably the best place to really get involved with these technologies. So if you're going to start to sort of play around with these things, if you have problems or questions, or, you know, need sort of some instructions, I would strongly suggest sending an email out to storagediscuss@opensolaris.org. We've also got a storage starter kit, which is built on the Open Solaris Open Storage Initiative that we have. And Jeff at the back, put up your hand, Jeff. Just the man with a bunch of USB sticks, because I know everybody only comes to conferences because you want cool stuff. So Jeff has cool stuff to give you. So it's a USB stick with the open storage software. And it's a starter kit that you can use to sort of play around with a lot of these things that I've been talking about today. So I've said a lot in half an hour. I guess it's your chance to ask questions, or you know, maybe we can direct this in other ways if you have some interest. Mark? Yeah.
So, how much of this is on the Open Solaris CD that everybody got with their T-shirt?
So, I would say...
is it NWS consolidation on that CD?
It's not available on the CD, but it's in the repository, so all of the...
Is it on the memory stick?
But where to get it is on the memory stick, yes.
Okay.
Yeah, so I think today if you want to play with Comstar, you do have to go to the project page to download the packages there. And that's the best place to start because, again, it's only been put back pretty recently, so I don't think it's going to be on that USB stick. Although, again, for the ZFS pieces that I talked about at the start, you can do all of that with the software that we're going to have on the memory stick. And for a lot of people, I mean, I know that at home when I want to screw around with technology, I don't have a fiber channel HBA lying around, and you know, unless you guys do, I mean, maybe you do. That it may well be that the iSCSI is more interesting for you to go around and have experimental you know, work with. And so you can actually get that from the ISO project page. Did we have any other questions? I sort of saw people, maybe they were just trying to leave. I don't know.
Since you have some time, why don't you tell us about Honeycomb?
Yeah, well, actually, I think there's somebody behind you that has a question. I can spend hours talking about Honeycomb.
Just a minor extension of the question the other person asked. But what is the plan to, when is it planned to be integrated with the ON or the NWS consolidation done so that it becomes available in the regular distro release?
So the Comstar stuff has just been integrated into Solaris today. So I would expect the next community drop to have Comstar as part of that. And so so that's the framework plus the fiber channel target pieces. The iSCSI and ISO pieces are the next pieces that are going to be integrated, and they're coming in August, I believe. At least that's what my team tells me. And then I think in a similar sort of time frame we'll also have support for SAS, and the fiber channel over Ethernet I think it is closer to the end of the year. So,
so the next, after the 6 months cycle, the next distro release is expected to have all this?
Yeah, so well this is also the other thing. We need to remember that we're talking about Open Solaris here. We're not talking about traditional Solaris. So we're a community, right? You don't have to wait until your son imprints a DVD to play with this stuff.
Files download page of the Comstar,
yeah.
Page on Comstar.
Yeah, so I mean, exactly. I mean, you can go and use it today. It's just, is it going to be in the Solaris, you know, Project Indiana, or what if that's Open Solaris, something, Developer Edition, something. I should know that, but I don't.
Yeah, that's fine.
Okay.
Can I
Sure. Are there? Okay. Well, I guess, yeah. Since we have a little bit of time, I can talk about Honeycomb. Yeah. I don't have any slides, so you'll sort of have to bear with me. But put up your hand if you've heard of Honeycomb. Okay. Cool. That's more than I expected. Put up your hand if you want to buy Honeycomb. Yeah. Don't scan the audience with the camera. So Honeycomb is quite an interesting technology, and it's really interesting from my point of view, looking at the strategy at Sun from that point of view, that we're looking at creating the ability to develop more appliances out of our technology. And I think the Open Storage Initiative is a fundamental piece of that. So Honeycomb is essentially more like a distribution than it is a technology. It's a fixed content object storage system that we've had, and we've been developing it for almost 5 years now. And we finally sort of started selling to customers about 1.5 years ago. And the interesting part of it is how much storage out there is devoted to fixed content storage. I think that when you first think about it, you don't really think that there is a large portion of the storage that you use that's going to be fixed content storage. But if you have a look at the way that we deal with technology today, what is it? I mean, like, I have a 9-month-old son, so I'm taking loads of photos. My parents live in Australia, my in-laws live in Scotland, and we see them rarely, which sometimes is a good thing. But, you know, they kind of want to see what's going on with my son. So, you know, we take a bucket load of photos, we stick them up on the web and say, here you go, you can check it out. And they get the benefit of, you know, feeling a part of it. But, you know, all of a sudden we have all of this storage that we're using that is never actually changing. Then, you know, the consumer society that we live in is telling us that, you know, 8 megapixels isn't good enough. We want the 25 megapixel camera that costs $5,000. So, you know, all of a sudden we go from, you know, being able to store 100 files in a gigabyte to, you know, it's like 10 files or stuff like that. And so there's a big push in you know, growth in fixed content storage. And so IDC was looking at it, and I think you may remember the numbers, Mark, but I think that it was sort of about 70% of storage was fixed content, about 30% of storage was mutable content. But first of all, what would happen is if it wasn't fixed content and you just waited for a period of time, so if you think about the way you use your laptop, there are probably a dozen files that you're using, modifying, or whatever at any particular time. But if you go back a month later, you're not going to change them anymore. So you kind of start to think more along the way of archiving. And how do you find those files? You know, that's always a problem. I mean, like, honestly, I'm sort of a Unix guy. I use, you know, find and grep and things like that. But my wife doesn't. My wife thinks I'm crazy, but you know, that's beside the point. So clearly when it comes to trying to find files and technology, so first of all, you know, there's a lot of fixed content storage. I mean, the 70% of storage that's fixed content is actually growing at 90% a year. Yes, I think that's the right number. And you know, that's growing far quicker than the immutable storage. So the amount of stuff that we're storing is far bigger, and we want to be able to find it. I mean, we have this deluge of information, and you know, I don't remember what the file name was called. I don't remember the path that file existed in. So Honeycomb is a technology that really is trying to address a number of these problems. You know, first of all, you want it to be reliable. You know, hey, I store these bits. I want to know that it's there when I come back and ask for it. You know, two, you know, hey, you know, where were these things that I stored? So Honeycomb has a built-in search mechanism, and that's sort of built on top of the fact that we have a very sort of flexible, user-extensible metadata framework. So clearly, I think that these things have been separated in a number of different ways. I mean, if you have a look at the way that a lot of file systems in the past, high-performance file systems, have tried to separate these things out, it tends to be quite different, and there's often very different failure characteristics between the data and metadata story that you have. Honeycomb sort of says that metadata and data are equal, because essentially if you don't have the metadata, then you don't know anything about your data. And so we do this, we build this up, and the metadata is sort of cached inside of a distributed database inside of Honeycomb, and that allows you to sort of rely on the appliance for your storage. But it also means that you can sort of forget about it until you need it. You can say, hey, you know, where was that file that, you know, where was the photo of my son playing with the bunny rabbit that I took in 2002? Although he didn't exist then, but you know, assuming he did. You know, you want to send that query, and you want it to send you back a set of photos that you need. So Honeycomb kind of does that. So I guess this isn't really why we're here, but I mean that's kind of what Honeycomb does. I think it's one of these things that is approaching cloud computing. So I've talked to a lot of different people recently about storage technology, and there are a lot of things that people want, and essentially they want horizontally scalable solutions. You know, it's sort of, I want storage, and you know, when I need more storage, I want to be able to add it, and I don't want it to be a pain. So, you know, if we have technology that scales simply like that, then that addresses a lot of the needs. And Honeycomb does that quite well. We have the ability to go from a single cell appliance to multiple cells to hundreds of cells that allows you to grow. You know, also a fundamental part of the cloud computing model, the data cloud computing model, is that you just want that guarantee. You know, it's sort of, I've given you my bits. When I ask for my bits back, I want them to be there. And what this is essentially saying also is that, you know, for data center customers, they really don't want to have to hire a new storage admin every time you add a terabyte of data to your data center. Clearly at the scales of storage today, that's not going to scale. And there's going to be a significant amount of money that's going to have to be spent on the administration if that's the way that we go. So the way that we do storage has to become simpler. It has to scale horizontally. And it has to provide a lot of these reliability guarantees. And the more data that you have, the more fundamental the importance of search technology to find your data. Anyway, we're significantly off topic, so if there are any questions on that, we'll cover that, or we can leave early and everybody can get coffee or hit the bar. Even though it's 2 o'clock. Anybody?
Unrelated, the ZFS port to Linux, is it going on or any status on that?
So ZFS, so it's a slightly complicated answer. So ZFS is supported on Linux today through Fuse. I don't believe that there's a port currently that's going to be done that will be in kernel. And there are a couple of reasons for that. I mean, the main reason right now is licensing mismatch. So, I mean, it's possible that we could do something similar to the way that the NVIDIA driver works, where they sort of ship the source code and allow you to each person to go away and build it. But I think the legal conflicts need to be resolved before there can be an in-kernel ZFS implementation. I see that I've stunned everybody to silence. So, okay, well, thank you very much.